Hiya guys, and welcome back to Wade's Workshop. So part 26 of the mini lathe. Yeah, 26 parts, can't believe it's been that many. Anyway, with that said, it's been a couple of years since we started it, so I'm going to carry on with the tailstock. Won't talk too much on the intro because there's lots of talking in the video. You will hear there's scraping noises coming through on the audio. I've got a round neck top on and it's rubbing on my neck occasionally, and that's why it all goes a bit muffled and what have you. So note to self, wear tops with zips or what have you moving forward. I won't demonstrate it because you'll hear enough of that crackling during the video. Anyway, enjoy guys. Right, let's get back to it. So, the hole in the underside, I measured before I put the block back into vise that from the edge of the hole to this space, because this side is the working face, this side's in fresh air, but to this space here, just to give me a reference point, 23.25. So that's from the edge of the hole to this space. The hole being 15, add 7.5, 30.75. So if I pick up on this space, step across 30.75, that will have those two holes in line, reference to everything. Okay, and then height-wise, I'm purely going to see what looks about right for this boss, and I'm going to be putting a 14mm hole in there. We'll explain that a little bit later, but so yeah, wobble pin up, pick off that edge, and then we'll have a look at what looks nice. This boss is actually out of line, but hey ho, it isn't much. So the hole isn't going to be concentric with this form, as it were, but it is what it is. So let's find this edge. First job. Oh, no, I thought my power feed was on then. It's me turning the handle. I can see the hand wheel turning that end. Okay, so there's my 0. Let me set X0, switch that off. So if I come across, okay, that's 2.5mm end on that, so 1.25. So first we'll do that and then reset our data. 1.25, X0, right. So 30.75 from there. 30.8, 30.7, 4, it jumped a little when I put the lock on, 30.75, we'll reset 0. Okay, so I am now lined up with the center of the hole in the bottom, so that's good. So we'll have that over there. Can I get my chuck in there? No, I can't. Let's just stand the head up a minute. That'll do. And the spanners reach around the camera. Okay. So, let's just drop the quill up. We'll put a center drill in there. Oh, I don't want one that's too big. Let's have a look. Oh, that'll be okay, I suppose. I was using a smaller center drill the other day and I've lost it. I bet I've vacuumed it up out of one of these slots in the table. I'll have a look in the top of my vacuum cleaner, I think. I think that's what I've done. Oh well. So, yeah, it's offset on that boss, isn't it? But that's fine. I mean, it is what it is. Right, I think what I'm going to do... I think what I should have done is found out where that is, and then I could have been a known distance from the bottom. You know what, I think what I'll do is go a known distance from the bottom of the block or from this space. It makes no difference really. This is in clearance, it's not doing anything. I'm going to do a known distance from the bottom of the block. So I'm going to come back out. I know I'm 30.75, I'm already stuck, got that. Have I got enough height? Let's have a look. That's on my top. Right, 30.75. I've set a 0 in X. That's fine, so I can come back to it. Let me get a position in Y. Send that down a touch. Okay. Oop. Come on. Okay. Y0. Let's have that out. Again, 1.25. There. Y0 again. Okay. So now I will know where I am in relation to that bottom edge. Okay. Let's bring that back down. That'll probably do me. So 30 point, oh no, what are you doing? 30.75 this way, which is now 0 because I've set a 0 there. Okay, fair enough. Okay, so let's have a look. What looks nice out there? What is that? 38 and a half. 38 maybe. Let's just, you know, I'm trying to get a round figure that I know where it is. That would be 38 mil. I am offset this way, but there's not much I can do about that. Okay, so I need a rule. So I'm going to have to walk around the camera, get the rules hanging on the wall. I can't reach that far. I haven't got long arms. I haven't got long legs either, but that's another story. So, this is going to be 14 diameter, so I'm just looking what this is going to look like. Is it going to stay within the boss? That's the main thing. Oh, easily. Easily. Okay. Lock X and Y. So that distance from there is 38. I'm going to write that in my book. So let's get the book out. So I've already written my 30.75, and I'm going to go from this space to my hole center 38. Okay, so I know how far from the bottom face it's 38 up to my hole, and from this space here 30.75 to the center. So I've got the reference if I need it. Yeah, X and Y locked. I'm going to give myself 0 there. Both 0. They are both 0. Right, okay. Let's start putting a hole in there. Okay, yeah, as you can see it's offset this way a little, but I want the two to be in line. I want it to be lifting vertically. What should we have? Let's put a 5.5 in there first. Oh, might need to go up on my head a little. You know what, I may have to change my work holding method, or my tool holding method. Out of curiosity, let's just touch there, set a 0. We'll see how thick the material is here. 8. It's about 9 mil thick. Okay. Yeah, about. So, yeah, height wise, my head is as high up as, where is it? It's got about 10 mil left, but my head is as high as it'll go. Let me just, can you see the chuck? Let me zoom up. Zoom up, right, okay. So my machine head is as high as it'll go, and my quilt is right up. And because I've got the ER32 holder, let me just go up a bit, Kane. ER32 holder and the chuck in that, I've got too much stick out here, which is sort of very limited on headroom, especially as I'm up probably 80 mil, is it? I don't know. Let's have a look. 85 mil up from the bed, and I'm wasting from my chuck to my top 150 mil, so I'm losing 6 inches here. So I think what I'm going to do is change my tool holding method. I'm always changing plans as I go along. I was thinking I want to put a 13 mil hole through here, so I was just looking around to get my 13 mil drill, and which I have got one, but I found this Imperial drill comes out to 13.3-ish. What is it? 1732. But it's a stubby drill with a step down shank, and it actually gives me the space I need. So I'm going to take this through here. I've got my pilot hole. So this hole is going to be diameter 14, and I'm going to bore it out. You know, I'm worried about that. Let me try again. Let me try. I'm worried that it's throwing too much, and I'm going to end up oversized. It wouldn't be the end of the world if I went bigger, because I'll make the shaft to suit. So. Okay, so a moment of truth. What? So, how sloppy is that drill in the hole, out of curiosity? Quite a bit at the top. Moment of truth. Where's the calipers? Let's just see what that measured up at. Can't find the calipers now. It's over there, because I put it over there to measure that drill bit. Right, okay, so the top of that is measuring at 13.86. Happy days, we can stay within our 14. Yeah, what was that? 1732. Actually, I'm thinking back to this cobalt drill. This was sent to me, a good few years ago now, by Everett, with quite a few sort of cobalt drills of various Imperial sizes. Everett from Everett's workshop. Haven't heard from Everett in such a long time. He's, I believe, has stopped posting on YouTube. Or maybe he's just taking a break like I did. But yeah, so I haven't forgotten Everett's workshop, and I don't forget most of the time where things come from. So again, they don't often come into use, but thanks Everett if you're watching. So I've taken the ER32 chuck out, and put the boring head up. Haven't got much to take out of this, so no, wrong spanner, right? So I got a spanner, it's a bit rusty. And 10 mil, yep. Okay, that's tight in there. So, let's just get set up with this. I think I'll use the same cutter as I used when I did the other hole. That worked quite nicely. And I need the Allen keys. Oh, I'm not very organised again. Right, it's one of these. I think it's that one actually, is it? Yep. So, set this up square to this space. Okay. And then I'll be pushing the cutter out in this direction. Okay. Can I get low enough? I can without even moving the head, and that'll get me high enough to get my gauge in. So I need to make another gauge, don't I? Let's just get touched. Right, I think it might be tapered, so what I'm going to do is, I'm going to be using power feed for this anyway, so let's start that up, see where it is. A little slow, don't you think? Let's just run that through, see what it does. I'm not expecting it to be touching in the top. I brought it close. Am I still on datum? Yeah, 00. Just making sure nothing's jumped about. Yeah, just a bit in the bottom. Right, what I'm going to do is switch on off and set Z0. I know that's passed through. Let's bring it back out of there. So I think what I'll do, I do need to make that gauge. Let's go another 0.1. So I'm going to run this through until it cleans up, because I know that's going to be about 13.8 something, or until it's nearly cleaned up. Let's just, and I need to turn another little gauge. I've got a telescopic will go in there, I think. You know, I could do that. Point one at a time. Touching about halfway down now. Okay. I'll let this run through. I might put another 0.1 on it. Run through and back out, and then I'm going to make that gauge. It's cold. Well, 14.009. Okay. It's another whisper. So I literally tapped the hand wheel on my cross light. It was showing us on a line, and I put it to on the line to off the line, as it were, a tenth of the way between two lines. Not sure if that's going to be enough. For 14.004. Well, if that moved, it was imperceptible. Not taking anything. It's not cutting. This should. Well, it seems to be lapping it more than cutting it. Are we going to be there? Gosh, how many cuts has it taken me to get the size, and I was only taking a mil off in total? Oh, 13.999. Okay. Right, let's take 0.1 off there. That much. And we'll go for about 3 mil, 4 mil. Okay. It hasn't thrown anything up. So on the end bit, I'm looking for... Should have gone a bit further so I can get the mic on it properly. 13.913. Okay, that'll be fine. So, let's just put a shutter on the end. And we have a new gauge. Okay. So that should have taken me about 4 minutes. It's probably taken me a lot longer, but I got my plug gauge. Okay, so I put another 0.1 on. Oh, I just tried that plug gauge in there. It was entering on the little chamfer. It sort of tried to enter, but there's nowhere that 13.9 was going in. So I've taken 0.1 off. Or put a 0.1 cut on. We got a little bit of overround in the top. So we'll try it again in a sec. I'll run this cut down and back out. So I'd already know the point where it stops cutting, which is 0 in Z on my DRO. So there's a DRO on the quill, which is the one that comes with the machine. And I've also got a DRO on my Z axis on the mill. So I've got 3-axis DRO on this mill, X, Y and Z. Back up. And because I looked a moment ago, I know I need to run it up to 45 to be able to get the gauge in. Literally, there's a little step in the bottom which it machined out, but the rest of it, it's not quite round, so it's sort of scratching on about 2 or 3 points. So 45, that's high enough. So, switch that off because that's a bit close. Yeah, I can feel the outer round in there. The 0.9 doesn't quite want to go in. So I'm going to take 0.05 out there and run it again. You know what, I hope this cleans up. I should do. Cutting the majority of the circle now, so I think we're okay. Otherwise I might have had to go on for a different size. I suppose with hindsight what I should have done was gone with 15 mil and I wouldn't have had to make another gauge. Not to worry. There is a reason I've gone for 14. So the shaft that fits through here is going to have a head on it this side, maybe 20mm diameter. Poke through there at 14mm, you know, or a nice running fit. And then the inside is going to have a 2mm offset. So I'm going to set it with a 2mm offset, which will give me a turn diameter of 10mm on the end, which is a nice round figure. And that 10mm is going to be the eccentric bit that lifts up and down on the clamp. So I will show you the setup of that part and machining of that. Let's go back up to 45. I should have used the vacuum on that, really. Right, the 14.9 goes in. The 15 doesn't. Still got a bit of rock in it, it's not quite cleaned up. I might have to go larger. That's another 0.05. That's touching all the way around now. It wasn't a moment ago. I could feel it. It was tight in this orientation, but loose in this orientation. But I can see it machining all the way around now. Oh well. We'll see. I might have overshot it with the drill. Okay. Okay. So the 15 goes in there, but there's a bit of movement in it. I'm not happy. It was the outer round that was throwing me all the time. I'm going to be making the shaft to go in here. It's certainly not going to hurt if I make it to suit. You know, that hole hasn't cleaned up everywhere. I can see where I'm machining it. I can see. I'm gonna go up a size. I'm gonna go up 0.1. I'd rather have a nice hole in there. I've gone up 0.1 and I'll have to make the shaft to size, that's all. Oh well. Being an engineer is not about not making any mistakes. It's knowing what to do when you've made one, or when someone else has made one. Today's my turn. Nice and slow. Let's run that through there. Yeah, that's definitely cleaning up now. Yeah, so basically you used the wrong drill. We'll run the same cut back up through. And that's going to slop about now. I think when I make my pin that's going to go in there, I'll make it 14.2. That hole should be, well, 14.1, but it's oversized. I'll make it 14.2 and then try it. Take the block to the lathe and just keep trying the block over the pin when I'm turning it. So yeah, that's going to be sloppy. Well, it was sloppy before, it's going to be even more sloppy now, yeah. Okay, but that has cleaned up all the way around, so it has machined it properly. So I have a circle in there now. Right, okay. I'm going to say that that's 14.2, and I'm going to amend it in my book to say 14.2, and then when I come to make the cam pin, 14.2, and then we'll keep trying it. Right, yeah. I am going to need... Now, I haven't got a facing boring head. If I did, I'd set it just 0.1 below that surface and I'd face it out. I haven't got one, so I'm just going to have to get a cutter up in here. Could probably, because I've got a step there, I could probably use the fly cutter and just offset it that way and just flash over. This surface is going to be in line with this surface, so it's going to clean this surface up as well. Okay. So I am 0.3 off. I just checked it, that back face. So the deepest I can go is 0.2 down from where I am now. So with that hole being 14, I'll probably make the rear of the shaft the stick out bit 20. So that would give me 3mm aside, and from this point to the edge of that cleanup is about 3mm. Right, now then, that step there, to my eye, is even all the way across. All that's doing is locating the plate on the back with the jacking screw in. It doesn't do anything. Let's take it from there. Let's just flash the whole thing. I'll slow down on the feed head, don't I? It's only 0.2. So I'm just thinking, last Christmas I had a new Noga which is up in my toolbox in the house, and I've never used it. So I've got two down in the shed, one which I bought originally and one which was donated. These two, and they're both pretty much identical, and they're both proper Nogas. That one's got a spare and that one hasn't. Has it got a spare in it? You know what, I've never looked. It has, it's got a spare arm. This one I don't think has. Oh, it has. Yeah, I got two spares in there as well. Right, okay. At least I know I got them. I need to deburr that hole, but I've got a different style one in the house, at least I'm pretty sure it is, because I haven't seen it for, where are we? It's 1st of October today, 10 months. So it's not a Noga, it's a rip-off one, but yeah, I mean it does the job, but yeah, different style. So I did it with the countersink because I had the datum. I forgot I still have the datum of where that was logged, but let's just re-establish the chamfer in those two holes, seeing as we've machined over the top. Yeah, works quite well. So yeah, I know it's not a real one, but what's the name on the handle? It works exactly the same. And I also got a pack of spare blades as well. I tend to not change the blades until you suddenly realise that it's just clicking and jumping around as you go around deburring a hole or an edge. So yeah, I've got some spares now. So we'll put that in the drawer. I compare it to a genuine one. Well, the difference lies, when you look at it, the only place the difference lies is it hasn't got the logo in the handle. And yeah, you can see the join in the mould in there a lot more than you can on a Noga. I mean, it's not as good, you know, but does the same job. So I've just come to the realization that theoretically that's all the machining of that and all the machining of that done. Yeah, I think it is. No more cast iron to machine, just a camlock mechanism to make now. So 4-jaw chuck, I've just clocked it up. My 4-jaw chuck was actually a little bit rusty, so I've cleaned it up with some Scotch-Brite. Here's a question for everyone. Anyone know where you can get Scotch-Brite without paying an arm and a leg for it? It normally comes in like 12-inch square sheets. You know, I've got some fine, the white, the brown, you know, that just various grades of Scotch-Brite without paying like £8 a piece for them, you know. Anyone's got any sources where I can get Scotch-Brite at a reasonable price? Because yeah, I failed to find it without, you know, paying an arm and a leg. So this bar's got a, it should be coming around this by here. See the clunk clunk? It's got a scratch in it along its full length, but I've just clocked that up, everything's tight. Now there is enough room in the bar, it goes back into the chuck, there is enough room to get the 2mm offset. So I'm talking 2mm in one direction. Obviously if this is minus 2mm, that's going to be plus 2mm. So when I come to set it up, I'll be looking for 4mm of deviation on the clock. I'll do it in one axis. Well, it doesn't actually matter as long as I've got 4mm of deviation when I'm done. But there is enough sticking out to get the entire part out of this bar. 32 and 10 near enough, 42, 20mm head, 62, and the entire length of this is me bumping the camera. I've got 70mm, so I've got 10mm left to play with, so I'm going to be parting it off about 10mm away from the chuck when we're finished. I will at some point, when it's running true, want probably an M5 tapped hole in the end to put a keep plate on. That's when it's finished. So I will put the hole in while it's still running true, and the offset will be the last bit I do. So we've all seen it before. First thing I do, that's running nice. This bar has a coating on it, like a chrome coating. I did say I wanted the bit with handle in it. It's going to be 20mm, but this bar is 20mm, so I'm going to have to get this coating off. So it's stuck out, well, not a huge amount, it is 75mm, but I will put a centre in the end at this point once I've based this off. And I'm going way too slow. So I have machined this piece of bar, which was fairly tough stuff actually. I have had pieces off it before, and I remember once you get that chrome skin off, it starts behaving itself. But yeah, I mean it's good tough stuff, so it'll do for the purposes of what I'm going to be using it for, which is the actual, let's call it a camshaft, shall we? Yeah, it is called a camshaft, although not in the traditional sense of the word. It is a shaft that has an offset on it that is behaving like a cam. So I suppose that does make it a camshaft. So yeah, just taking you through my thinking as we go along. I have a sketch. I've done some measurements. So this is going to have 3 diameters on it, 2 concentric ones and 1 offset one. So let's get a centre up, shall we? Get rid of that centre drill. Get rid of my chuck. Okay. And put the centre in. Okay, can I reach with the centre in? So first thing I'm going to do is clean up this diameter all the way to the chuck. Use power feed. That's a bit fast. So I put a 0.2 cut on, see if we can get straight under that skin. I can hear that little scratch in it. Weird, it's a scratch about 0.1 deep all the way along. Well, it might be deeper than that, but the clock was deviating by 0.1 as it went over it. And then the clock's got a broad base on it. So I don't think it was hitting into the depths of that groove. So, nominal size, 19.38, something like that, 36. Okay, that'll do. I'm not worried about that. Yeah, so that divot was deeper than I thought. So first shoulder, I need to turn it back to the 14 point something, which was the hole that we did oversize. I'm going to go 14.3 and then we'll start playing with it. But over a length of 42mm. So I'm going to set the datum. Okay. So there is approximately 19 point something, wasn't it? So it's 5mm approximately. In fact, it was 19.36. If I took 5mm off from the touch, I'm going to be oversized, so I'll probably take about 4.8mm off. So let's get that cut going. That's the slightest touch. I don't know if I can do it with the tailstock in the way. That's 1 mil. And 42 I said. That's a coarse speed on there. So I'll stop at 41. .5, we'll call it. There. Right, I've got a visual point now. That's 2 mil. Just taking a mil a side off, a mil and a half a side off actually. But I got a really coarse speed rate going on here. So I got carried away in the moment and finished that diameter, and I finished the face. So I just take my block. That fits in there. Nice. Okay. Ooh, right, okay. So the distance to the eccentric part is 9.3. So overall length, that's not important for now. Let me just wind that off. So I've set the DRO on that face there at 0. Let's just see how repeatable that is. Okay. That could change when I offset it. So let me turn that feed off. So what I'm going to do now is get the clock set up and get this offset done. I need to just chamfer that top edge. Yes, let's do that now. I mean, I don't want a big chamfer on it because that'll remove the land off it, but let's just a nice break edge. I think that'll do me. We've got a bit of worn out emery here. Let's just polish that corner round. Finish on there is okay. I may give that a polish up. Do I? If I'm going to do it now while it's still round. No, because if I polish it, it might go out around and then it'll affect my clocking. No, it won't. You're just being silly, Aid. Let's have a... see if I can just tidy that up a little bit. This emery's a bit fine. P400. It's only the last 20 mil that's doing anything. And we'll have a little polish on that. Don't want to change the diameter, just tidy it up. Right. So I need to do the offset now, so time to get the clock out. Let's get the tool out. Let's get everything out the way that we don't need. So I'm still machining away. It's coming truer and truer. I'm probably about halfway now to getting the, I think we're about 12 mil diameter. It needs to finish at 10. I've got a stop set for my distance. I'm using the power feed, which my power feed's up on the wall there. And the motor's running away on the other end of the shaft, which is mighty unconventional, the way some people do it. So yeah, I had the camera mounted up in the roof, up on that shelf, on an angly bracket. Well, in fact, I used, let me see if I can show you, where I normally have it is in that vise. I had that vise up there, hanging upside down. I went up for a bit of a break, uploaded the footage I had, and it looked weird. It was just upside down and horrible. And that was all the setup of the offset. So I'll just run through that quickly again with you. I'll run this cut through and I'll run through that with you. So this is going to be difficult for me to show. So the part in the 4-jaw chuck, first thing I do, if I set that up, I want this part to be running 2mm offset. But of course, if it's 2mm one way, the clock's going to read a variation of 4mm. I'm on a metric clock and it's 1mm per rev. So let me just find the low point first. Low point is there, right? Okay, if I just bring the clock off, wind the carriage back in till I'm on 0. There we are, we're on 0. Right, so if I rotate the chuck now, let's come back a bit, you'll see 1 turn, 2 turns, 3 turns, 4 turns and a couple of hundredths. So basically I started off with the part running true. I loosened off this jaw, 1 full turn, and then tightened that one on the other side 1 full turn, and then checked these 2 jaws, the top and bottom, just as they were still tight, and they were actually become quite loose because I'd come off the apex of the part. So I just nipped those 2 back up equally, then measured the rotation, and it actually gave me about 1.1mm offset. So I did another half turn, kept going, and eventually, by just tweaking the 2 jaws, managed to get to within, 2 tenths. 2 tenths, 0.1, 0.02. Okay, so that's how I did it. Just offset it until the clock reading from high point, low point became 4mm, which gives me 2mm offset, because I'm measuring the high point 2mm in one way, higher, and then 2mm minus the other way. So yeah, so that's all I did with that. So we're getting down to size now, probably about 3/4 of it cleaned up around the circle. Why did I decide on a 2mm offset? So 180 degrees would give you 2mm lift, 2mm drop. The handle on the tailstock is only going to go about 1/4 of a turn, about 90 degrees. And that will give me a lift, 90 degrees in effect, of 2mm, which I think is going to be more than enough to pull up the clamp plate and tension it. Obviously, I will adjust the bolt length underneath so that there's enough movement in that 90 degrees between completely slack and the tailstock allowed to move up and down wherever it wants to, and then tight enough that it's lock solid. So that's why I went for the idea of 2mm. I'm just going to have a look at that, because I think we should be getting somewhere near now. So when this cleans up, because this was 14.3, let's say, 14.2, 14.3, there's only a small area that's not cleaned up. This, in fact, it's probably about 6mm wide there. When it cleans up, it's still going to be over 10mm, but I'm going to go for a 10mm circle. So, yeah, I've been taking 0.5 cuts. I'll just go for 0.25, see what difference that makes. I can hear less and less intermittent now. I can still hear that sort of gudder, that noise, but it's becoming more consistent, the cut around the diameter. We just, in fact, I think that's going to be very close, that. I'm glad I didn't go for the 0.5 cut again. So I've faced it up to 9.37, that shoulder there now, the 14mm one, 14 point whatever one. Sorry, 9.37. It's got to be 9.3 when it's finished, which is slightly thinner, 0.1 thinner than the thickness of the cast in the back of the tailstock, now that I've machined it all up. I took a measurement of that earlier. That's 9.4mm. So yeah, it's just slightly under that because I don't want this bit sticking out. It'll all become clear. Yeah, I want it to be 10mm. It's going to be running in a slot. Or a circle. Well, I don't know what it's going to be running in yet. It'll either be a 10mm slot, side to side, so that it can lift up and down without sideways affecting the part, or it'll be like a 14mm hole, and then I'll adjust it so that the top of the hole's in the right place, if that makes sense. Back finish doesn't look too bad, so I don't think we're going to have to mess with that tip. Might see if I can speed it up a bit to the point where it starts shaking, just to, because I am running very slow. I'm only running at 500 RPM, and for 10mm diameter that's a bit slow. Might be alright for high speed steel, but this carbide tip, okay, it is still actually about 2mm wide. So I ran that cut, it had just cleaned up, and it was measuring 10.3. So now that I'm not doing an intermittent cut, I've sped it up, I'm doing 700, I can just feel the slightest vibration. So I'm doing 700 RPM now. Okay, so I'm going to say this is finishing cut. I've already done the shoulder to the 9.3. I measured it up and I got 10.03 the one end, 10.04 the other. And it was bigger at this end, closest to camera. But I will polish that out if I have to afterwards. Only 10 microns. We'll be fine with that. Just so I got something true to start with. Okay, so proof of the pudding is in the eating. 10.001. 9.986, so it's a bit smaller on the end. It's actually, let's measure that again. 10.001. 9.987. Okay. Yeah, that's fine. Right, so what I will do, while I've still got it in the offset, and it's easy to do, is put chamfer on the end. Only small. I'll do that. So I can't do any other chamfers because I'm all on the wobble. But that is the offset done for the cam. Right, so I put it back in the 3-jaw chuck. The guard does that sometimes at the back. Just rubs on the end of the spindle. What are we doing? Right, set that at 20mm. Let's part it off. I got a bit of MWF on my acid brush. Just helps stop that tool weld. and I'm running at 500 RPM straight in with this parting tool, and no dramas whatsoever. That's nearly off. Part that clean off. There you go. So yeah, what's with all these rear tool posts, upside down tools? I've got a 2mm wide parting tool, compound slide replacement, solid tool post. I mean, all this was made by myself, and it just parts off anything, no problem, even stainless. You know, what's all this fuss about parting? Tool's nice and square. It's got these blue nano tips in it, but these, I think I've had this tool probably 3 years, 4 years, and I have only probably on the second tip, so I've used 3 edges. So yeah, parting not a problem on this mini lathe at all. Yeah, if it's a compound slide, slightly different story. Cheap, you know, aluminium tool post, slightly different story, but everything's fairly rigid, and I personally don't have any problems with parting off. So right, okay, so I put that slightly oversized when I parted it off. What did I make it? I can't remember. I think it was about 0.3 over. 20.35. Right, size doesn't matter here. It's a nominal. Just hold on there. I'm going to touch on there. Take 0.35 off there. That guard's rattling again. Yeah, that's 0.32. Come on. Okay. It's going to be 20mm near as what's it. So while we got it here, let's put a chamfer on the end. This can be fairly big. Let's slow down a touch. Stop the vibe. Slowed it right up just to take the chatter out. Right, okay. Now the only thing I want to do now is in this end where I centre drilled it, I want to put, you know, I might go M4 in there. That should pick up on centre again there. How's that centre drill look for running true? Not bad. Okay, am I going to push the centre drill back in there or just drill it out? 4.2 for M5 or 4.3 for M5? 4.2. I think I'll just drill it out 4.2 where it is. $15 turns of the hand wheel, so that's 15mm deep. Get the M5 tap and just start that by hand. In fact, I've still got the M5 tap out, I am not going to snap a tap in here by doing it with power feed. No chance. Not after the amount of work that's gone into this so far. Okay, just started that thread so I can get it square. Yeah, I'm not going to gamble it. I trust myself with a T-handle, a tap wrench rather, to tap out a hole like that in a part where I do not want to scrap it. So yeah, there is the cam. I may have to reduce this length, but and I can always redo the hole in the end. That's going to be for a keep plate afterwards. And obviously there will have to be a cross-drilled hole in here, perhaps a spot face on an angle for a handle to come out. We'll see, but I need to get the rotational position of where I want the handle based on where it locks up. You know, I've got to tune that and put the hole in the right place when I know where I want the hole. So if I take the shaft, fit it in from the back of the tool stock, and there we are. There's the offset that does the lifting up. Okay, and you can see the tapped hole is straight, so that when there's a keep plate on the end, it is going to be shorter than that. When there's a keep plate on the end with a bolt in it, you won't see the cam operating, you'll just see the block with a hole in going up and down. So yeah, that's a bit of fun. Yeah, okay, so far so good. Happy days. Well, I think we're going to call it the end on this one. So yeah, probably an hour and 6 minutes long, something like that, this video. But we're getting there. We're getting to the nitty-gritty of having this tailstock finished. Few little details to go now. I've got to make the block that goes up and down. I've got some ideas for that. That'll be coming up in next week's video. Yeah, probably by the end of next week's video we'll pretty much be finished on this tailstock, and then we can move on to other parts of the mini lathe. There are quite a few more bits to do, but it is what it is, and we're getting there slowly. So anyway, thanks for watching, thanks for subscribing, and we'll see you all very soon. Cheers now.